All right, so we're going to go to the virtual machine and we're going to do this. Okay. So let me do this. All right. So I'm kind of doing the digital signature part. So I'm going to call this like create a certificate authority and then digitally sign a public key, right? So that's kind of what I'm doing here. It's really that part that I described. So let's open up the terminal. All right, so let's go into Ph.D. ATS 350. Okay. So I'm going to go into certificates. And since I have a whole bunch of keys here and things like that, I'm going to create a new folder. Okay, so mkdir. And I'm going to call it digital signature and CA. Okay, just something. All right, so this is, as I said, you guys are going to need the public key of the recipient, right, to be able to send them a symmetric key. But how do you trust that key? So in the homework, as we have structured this, we've basically defined that we're just using E and N, right, as the parameters that define a key that go into our code. So what I was saying is just create a file, call it, to be consistent with the example, Alice pub txt. Alice pub .txt. Okay. And when you open this, you can just say, pub equal parentheses like that, right? Why? Because we can sign any file that we want, right? It doesn't really matter. And when you guys take this information, which is E comma N, you just hard code it really, right? You copy and paste it into your code, or maybe you read it in, can't remember, right? Okay, so this looks, just to give you an example, this looked like, I think the E was actually, what was the number? 56337? 55.5. 65.5. Repeat. 655. 65337. 65537. Where? Here? Yeah. And a 7. Okay, so that's probably correct. It's not? 37. 37. Okay. Right? Right. And then this was some long number, right, that you guys calculated. Right. That's it. That's the public key as you have used it in the previous problem, and we can use it as is in this one. But this is the thing that you want to sign, digitally sign, because the certificate authority is somebody you trust, right? That's the key thing, right? So we can go ahead, Control X, Y, clear. So our file is there, should be fine. Now we're gonna go ahead and do, and now I'll just write here, create the CA entity. What does that mean, create a CA entity? Really, to create a CA entity, we just need a public and a private key in its simplest form, right? We don't have to create the whole formality of it, and I'm not asking for a certificate either, right? So just create the keys, okay? So then we're going to create the CA entity, but the files I'll name CA. So we can do OpenSSL, GenRSA, dash pass out, which is the way that I wrote this on Tuesday, some password 13579. dash out, and here I'm going to call it CA private. I recommend that you always do this so that you don't get confused as to which keys you're using. Dot PEM. These can be PEM files, right? Because we're using them separately from the other infrastructure. Okay, we just need these to verify, sign and verify. The size of these, 1024. Okay, hit enter. Okay, so we've done that. We can cat CA, and we've got it there. Clear. Dash L. Oh man, did I do this in the wrong place? Okay, so I'm gonna move it. Sorry, I did this in the wrong place. 1, 2, 3. All right, I have them in the right place now. Okay, so this is the folder where they should be. Just to remind you, cat Alice, that's just the public key of Alice, right? And then we've got the PEM file, CA, then we got it. Okay, so now that we've created this key, we're going to create the, let's see. Do we need to have a public key here? We have a private key for the CA. Why?
So we need it when we're gonna
check. Yeah, exactly. Very good. Very good. Excellent. So then let's do OpenSSL RSA dash pass in the password pass 13579. Okay. Dash pub out dash in, and it was CA. This is the CA private PEM dash out. And we want to call this definitely CA public. Yeah. .PEM. Okay. So this creates the certificate authority entity. There is a specific process in Linux and OpenSSL to do that. I did that on Tuesday, but we don't have to do that process. We can just do it like this. Okay. So there I've got the third entity. Just this means the third entity. Okay, guys? And so you guys, somebody has to assume the role of the CA entity and perform the process, and then the CA public would be available to everyone as they are.
Okay. It doesn't have to be a .PEM file, right? It could be anything.
You mean the extension, but still using OpenSSL? Yeah. Yeah. The extensions in Linux are not really that important.
Okay.
Yeah. If that's your question.
Yeah.
Yeah. All right. So now we are ready to perform the process. And what we want to do is create the digital signature. So this is the problem. I mean, so that I assigned today, but you have to do the whole thing, right? So the whole exchange, because it's complicated, all the keys, etc. So then you do, now we sign. So let me write here. Now we sign Alice's public key. Why do we do that? We sign it because we trust the CA. The CA is somebody that we trust, and we're going to have their public key. We have that too. And so then we're going to know, okay, no, that's the CA says that's Alice's public key. I trust it. And that's how the internet works, basically. Okay. So then, all right, so now we sign Alice's public key. So we're just going to repeat this process. I'm going to do open SSL DGST. So now we're signing. Remember the process we talked about. So there's integrity and encryption with RSA, right? So we're going to use SHA-256, SHA-256, right, to get the hash. And then the hash is the thing that we encrypt, okay? So let's go ahead and do that. We have a command dash sign. And here we need a private key. So this is being done kind of, it's a very important step. It's done kind of by the I just said it, by the certificate authority. So obviously the key that we are going to use here is the CA private. Does this make sense? That's somewhere in here. Over there. Yeah. CA private. See, this is the file that I said, right? Key. And we should get the digital signature. So now let's go ahead and run this command. So CA private PEM dash out. And now give this some name because this is the actual digital signature. So what would be the appropriate name for this? It would be Alice Hub that signed by CA. You see that? Just, something very descriptive and clear. And, by convention here, they're using the hash algorithm. So SHA-256. Got it? All right. And then now we need to sign something actually, right? So we haven't actually, so we're just define a whole bunch of methods and things and the output, but we still need to define an input. So what is the thing that we sign? In this context, alicepub.txt. Make sense? It's fine. It doesn't have to, so this was Ben's question. It doesn't have to be a PEM really. This would, any file should work. So I'm going to do alicepub.txt. Okay. All right. So I hit enter, ls-l. I have a file. I can cat Alice pub signed by CA, right? You can see it's encrypted as it was before, right? Now, let's think about the following question. Let's look at all the files. And now, who needs this in our logic, in our process? Bob, right? Bob is sending. Yep, exactly. Bob needs the public key. Bob already has the public key because it's public and therefore it doesn't need to be encrypted and is shared with everyone in the world. So Bob already has Alice. I should have given these different names. Alice, Bob has that. No confidentiality needed. That's the public key. It's freely available. That's not what, so it doesn't feed into the process. What Bob wants to do is, hey, I have this and I have this digital signature by the CA. Does it check out? And can I trust this to be, because the CA did this personally, like they did it and they can be trusted or otherwise they'd be sued and things like that. So then you can go ahead and now you need to check it out. So that's to verify the signature. We have the following process. So we do open SSL DGST dash SHA-256, right? Because we have to take something and encrypt it, right? So we're going to think about that. And dash verify. So now we change the name. Here we need a public key. Right? So public key?
Calix.
CA. Why the CA? Because the CA signed it and we're authenticating, right? So think about that. So we're gonna sign, this is the digital signature. So we are verifying, right? I'm gonna do verify. And this should be, what was the name? CA public. Very good. Public dot pen. Remember, it was encrypted with the CA private, only the CA public can decrypt. That's the math relationship, the magic. All right, so CA public. Then the inputs is the signature itself. So dash signature. And what is the actual signature? It's going to be this file. So this file needs to be there, attached basically to the public key. Okay, so there's no idea here maybe of sending from Bob to Alice or Alice to Bob. Just imagine that wherever you find Alice's pub, next to it, there's a digital signature. It's a second file. And the digital signature says, by the way, this was signed by the CA. And guess what? Both Bob and Alice trust the CA. If they don't trust it, this doesn't work. But they do trust it. Okay, so that last part, there's no sending necessarily, it's just somewhere in the web. They're together. All right, next to each other. So now we feed in the signature, which is going to be Alice pub, sign CA. Okay. And we need one more thing. What would that thing be? We need one more thing here.
Oh, the plane.
Why the plane? You're right.
Yeah.
So, well,
I'm not sure exactly right, but I know that.
yeah. All right. Yeah. So we'll go over digital signature again on the board, but yeah, exactly right. We feed in the which should be what? Alice pub txt. Alice pub txt. Verified. Okay. Do you guys see that? That's it. You just verified it because you trust the CA. You've got the CA's public key, and this whenever the CA says, it's like, what's your name? Baya. So if Baya is the person you trust, right? And Baya just in person gives you, here's my public key. I signed something, you can trust it. You see what I'm saying? So that's how it works. So you just need that public key. We're going to do a future lab where we're going to see that those public keys are in the browser themselves. So like in Mozilla, you can just upload your keys and then you'd be a certificate authority yourself. Okay. All right. So that's the exercise. Okay. Let's do, I guess, how digital signatures work. So this completes that part, right? Are there any questions? Yeah, go ahead, please. Well, you're still, so after this, you've got the public key, right? And so, which was this one. So that's a good question. So I guess you're right in the sense that this part you probably do on your own, right? Whoever's sending it in the process, just describe it really well. So where you did get Alice's public key, right? Where you in the process where you started and said, hey, here's Alice's public key. Now you're going to add a little section where you're going to say, by the way, I need to check that this is in fact Alice's public key. I need to do the authentication. So here's the certificate authority part. Make sense?
Well, that means I don't even have to work with my partner.
Not necessarily. Yeah, you're right. It was a good question. Yeah, you're right. For that part, yes. But for the rest, though, you do. Yes.
So what is the point of the certificate authority? Like
Authentication. Trust.
why not just trust the person?
Because in the internet, you go to a place and they give you a public key and they say, hey, here's my public key. But now they're going to give you the public key and the digital signature. So the digital signature is created from the public key that they provide. There's two files. But in your browser, you have VeriSign. And VeriSign's public key is there. So people want to not just make their public keys available, but they want to make their public keys available signed by VeriSign, because it's an extra layer of security. So that when you get the pub, it's not just Tim's pub, it is Tim's pub, but signed by VeriSign, and I trust VeriSign.
Okay.
So that's if, like, if someone were to like tamper with the public.
Yeah,
they would
exactly.
not check out.
Exactly, because remember, it's like another layer on the key. It's not like separate in the website. I could go to the website and say, hey, I'm, Bob, and here's my key, and you can trust me. I'm a good person. But it's just the key.
When the Gen R, like when you do
Yeah.
the certificate authority private key command, what are you doing when you do Gen RSA? And you pass it
I
out?
create which part? Let me see the first
Like
one.
the first thing you do.
Yeah, so sorry, did I answer your question? I was answering. Okay, so let me go back. So the very first command was even before, like this one. Yeah, we created the private key, and then we created the public key. So in 2 steps, I created both the private and the public key. What I did there is I literally created a new entity called CA that has 2 keys, a private and a public.
So in our lab, what do we get that from the code from last
Just
week?
do this. Just do this. You would create a CA. By doing this and
You
name,
don't- So you don't have to do the 2 steps of getting a public key first and then.
well, no, you do. So what I just did is I did a private key and then a public key.
Right.
So I did it in 2
And
steps.
they're signed like you.
No, these are just the keys of the CA. So there was no CA. And after you have a pub and a private called CA pub and CA private, you've literally created a new entity called CA. That's enough for this exercise.
Okay, so we're not actually.
Right. You're not following what I did on Tuesday, where I actually created a whole process.
Okay, yeah. That's what-
I'm not asking for that right now, because that would be even more complicated, but you will have another lab where you do that.
Okay.
But right now, this is easier, supposedly. Got it? And also, actually, I think it removes a lot of the complexity so that you drill down on what is really important, because you should be very clear and comfortable with the idea that just by doing this and signing with the appropriate keys, if you trust that, then that's a CA. You see what I'm saying?
Yeah.
Because that's the whole thing. The whole thing is, if you use a private key and then you can decrypt it with a public key, right? And you're basically signing or encrypting a hash, right? That's a digital signature. And then who signed it? If it's someone you trust, then that's good enough.
So we kind of have like 2 steps or 2 layers of security in this, but normally you kind of have like, or we kind of have only 1.
You
have,
without the CA, you mean?
yeah. 'cause
Like what we did in
we're
the
not-
previous homework?
Yeah,
Yeah,
we're not.
but you don't, how do you know that key really
Yeah.
belongs to? It's really like you're saying, before there's Ben and you guys, know each other. But if you don't know each other and you want to do business and the business requires the use of public and private keys, what do? You go to a bank, maybe, right? That's what you would have done in the past, right? Let's go to a bank. Hey, can you help us with this? We want to do business and we don't know how to do business. And the bank is like, what if I create my own set of keys and then sign your public keys? If you guys trust me, then, and that's authentication. It's literally that simple. It's just like another layer where there's some kind of an agreement. And that's why I keep saying you have to trust the CA. So like VeriSign, go do this with VeriSign or Google,
Yeah.
somebody that you trust.
We're just like pretending.
You can create an actual CA in Linux, as I showed on Tuesday, or just do this, and this should be fine also. As long as that CA private is kept private and you trust whoever did it. Maybe you're the IT administrator of this whole group, so they trust you because you work for the company. You see what I'm saying? That it's that simple. There's no magic there. It's just the same public and private, but with the implication that you trust whoever holds these keys. Good question. All right, we were gonna do the digital signature again, right? So remember, this is in the slides, the diagram. I'm just gonna draw it now on the whiteboard. So let me see if I can do that. All right, so that with that code that I did, and actually bio, your question was really good actually, because yeah, you don't have to exchange that part, but still do it for the problem. Okay. All right, so let me get that. All right, so, all right, digital signature again. So this is pretty much what I said on Tuesday. I'm just repeating it, the process itself, right? Digital signature. And what, there's no real difference between digital signature and certificate authority, right? At this point, you guys, basically, they're doing this very similar process or the same, except that with the certificate authority, there's this entity that you trust, basically, like a company like VeriSign. So you've got what? In our example, a plain file, right? Not TXT. To be more precise, we were holding Alice pub. I like this example because it highlights the fact that this does not need to be encrypted, right? This does not need to be a cipher, because we all know that by definition, Alice's pub is known by everyone, right? It's in plain text, it's available. That's the whole point. All right, so what's in a digital signature, you're going to encrypt, but you don't actually encrypt this file, right? Because it's better to encrypt the hash of this, right? So what was the hash? You know this already. That's what we covered at the beginning of the semester. It covers integrity. And you've noticed that we have been using SHA-256, correct? Do a circle here. And that gives you then a hash value, which you guys remember was what? It was like 256 or 128, and it was just like hex values, right? Something like that. So hash, to remind you, it's just like a sequence of letters and numbers, right? So BF, 3E, something like that. Okay, now you take this hash, and what do? Now you perform encryption, more specifically RSA type of encryption, correct? Okay, and what do you plug in here? You plug in the CA private. Very good, because that's what provides authentication. Remember that this is, we started with confidentiality, then integrity. All semester we've been exploring that, and authentication can also be provided by encryption, right? So not just passwords provide authentication. So if you think, so all we did is we took this sequence of letters and numbers, right? Maybe a size 256 at most or something like that. And we encrypt it, and then we get the encrypted, we can call this one the cipher. But if you look, the digital signature might seem like it's some big thing, and it's really just this thing encrypted. Do you see that with RSA? Okay. Now, officially, the document that OpenSSL creates might have more details because it's OpenSSL. It's the implementation of the program is different from the actual algorithms that are required, right? Okay, so then this is done. And then what do you send to your partner? You send the cipher here, which is the digital, I should call it the digital signature. And in the context of the Alice's pub, they probably already have it, but these two are like together, right? They're a pair. So that's it. So that finishes this process, right? It goes in this direction as the arrows point. Now in the other end, right? Want to verify, right? You have two inputs. So you have Alice pub once again, and this is just a plain, I'll say txt, plain text. Okay. Oh, txt, yes, sorry, that's what I wanted to do. Like that, right? What else has to feed into this? The actual digital signature, right? So that this file over here, cipher. So cipher digital signature. So again, this, Obayo's question was really good because really you don't have to send these, you don't have to imagine that you're sending these. Instead, you mainly imagine that they're in some website. Now these can be placed in a website. And even though, what's the difference here? Even though a hacker comes in and something like and changes it, let's say that they change it, right? That they put an Alice pub. So this is actually maybe to answer your question. Let's say a hacker hacks this website and they replace this file and call it Alice pub, and they provide a cipher and they call it cipher digital sign for Alice pub, these two files, right? When you do these to check, is it going to verify?
No.
Why not?
They both don't hash to be the same.
But why?
The Alice pub got changed.
Yes. And what's the thing that
Because the authentication, the private key is not going to be the same. Like if
Though-
a hacker.
exactly does the hacker have the private key of CA? No. Why? Because we keep private keys private, and VeriSign cannot share their private key, right? They'll lose their business, and so they're going to protect that like you have no idea. And so therefore the hacker would have they can go in and change this and this, but they can't change the fact that it was generated with the private key of VeriSign or the CA. Does that make sense? So that's the fundamental thing. So they can go in, hack in there, but they don't have CA's private. Any questions? I mean, yeah, okay. So they would have to like go in, hack into your system and put in their public key there, and it's too involved, right? Yeah. All right, great. So anyway, so let's finish up digital signature here. So now what do we do? What do we do here? We take the digital signature, right? And we're gonna decrypt this digital signature using RSA with what? CA public, right? Only the CA public and nothing else can decrypt it. Okay, so what does that give us when we decrypt it? Gives us the hash, right? And let's say hash A, and so it gives us hash A, right? And so now what happens here? We have Alice's pub. If you remember, we did Alice pub hash and got this, right? So then here we do the same. Hash SHA-256. We can do that. No problem. And what is that going to give us? Hash A, correct? And guess what? These two need to be the same. If they are the same, then verify says okay or true. Otherwise, it says false. So if one bit, which is what we did on Tuesday, one bit, and it's part of the homework, one bit of this file is changed, this is a totally different hash and it won't match here. Do you guys see that? Also, if somebody hacks the website, changes things, it's not, this won't decrypt correctly either because it's not going to be the CA's pub. And that's it. That's a digital signature right there, which is what we've been doing with OpenSSL. Any questions? So I think I'll stop the recording at this point, right? And I'll just post this video. So let's go ahead and stop it. And I'm going to end it.